All right, at the end of the last video, I gave you this lovely function, and I asked you to find a whole bunch of stuff, starting with the intervals of increase and decrease, and the relative maxes and mins. And all of that we're going to get by looking at the first derivative. Probably should have warned you, this is a tough one. So if you got started, didn't get all the way through it, I hope you're not beating yourself up. I hope you're paying attention, and we'll work through it together. Okay, so f prime of x is 10/3 x to the negative 1/3. 2/3 minus 1 is 2/3 minus 3/3. So I'll get a negative 1/3 minus 2/3 x to the, this power will be negative 2/3. And I think I'm just going to rewrite that as 10 over the cube root of x. So remember, the negative exponent tells me it's in the denominator. The fractional exponent tells me there's a root involved. Okay. Same thing here. I can say this is minus 2/3 the cube root of x squared. With a fractional exponent like that, the denominator tells me which root to take, the numerator tells me which power to take. And the cube root of x squared is the same as the cube root of x squared. So it does not matter what order you do the power and the root in. Okay. I kind of like to have it this way. So for calculus, I prefer to have my roots written as exponents. For algebra, things like figuring out where something is 0 or undefined, I prefer to work in roots. And something interesting is happening here, because when I rewrite it this way, it becomes obvious that I've got some denominators here when I didn't in the original function. So if x is 0, this is going to be undefined, but the original function is perfectly well defined at 0, because I can take the cube root of 0. So this is the first time we've seen this, but we've got a critical point if x is equal to 0. So we've got a critical number because the derivative is undefined, not because the derivative is 0. Now, that's not to rule out that we have other critical numbers, so let's see. Let's see if there are numbers that would make this thing equal to 0. Now, I'm not crazy about having these x's in the denominator, and there are a couple of ways I could get around that. What I'm going to do is I'm going to just add this piece over, because then I just will have a fraction equals a fraction. And I can cross multiply, and that'll get rid of the denominators. So this diagonal product is going to be 30 times the cube root of x squared, and that's going to equal this diagonal product, which is, I'm sorry, I dropped a 3. This should have been 10 over 3 times the cube root of x. So there should have been a 3 here and a 3 here. My bad on that. So this is going to be equals 6 times the cube root of x. Now that I've gotten rid of the denominators, I'm going to go back to subtracting this over. So 30 times the cube root of x squared minus 6 times the cube root of x equals 0. And now I can factor. I'm going to factor out a 6, and I'm going to factor out a cube root of x. And that's going to be times 5 times the cube root of x minus 1 equals 0. So this will be true if 6 times the cube root of x equals 0, which would be if x is 0, except that's not actually a solution to this equation because 0 was not in the domain of this expression. Okay. Now, 0 is a critical number. It's just not a critical number because the derivative is 0. So I'm not going to have a horizontal tangent at that point. In fact, the tangent line is going to not exist at that point. Okay. All right. Here, if 5 times the cube root of x minus 1 equals 0, then 5 times the cube root of x equals 1, cube root of x equals 1/5, and x is going to be 1 over 125. So, we have two critical numbers, one because the derivative is undefined, and one because the derivative is 0. So, I'm going to draw my number line for f prime. I'm going to mark off 0 and 1 over 125. And now I want to be very strategic about the test numbers that I pick for each of these intervals. Here, I think I'm going to pick negative 1, because that's easy to take the cube root of. Okay. Oh, I inadvertently erased what this was written in terms of roots, so let's rewrite that. Cube root of x minus 2 plug in negative 1. This one's complicated enough, I'm going to write it out. I'm going to get 10 over 3 times the cube root of negative 1, would just be negative 1, minus 2 over 3 times the cube root of negative 1 is still negative 1, but I'm squaring it, so times 1. So that's negative 10 thirds minus 2 thirds. A negative minus something, that's going to be negative. So notice, as soon as I know what the sign is, I can stop. I mean, I could keep going. That's negative 12 thirds, but I can stop at that point once I can see what the sign is. Okay. Now here, that's a fairly small interval in which to work. So I want to be very strategic and very lazy in choosing my point here. I think I'm going to choose 1 over 1,000, which happens to be 1/10 cubed. So it's going to be easy for me to take the cube root of that. Because 1,000 is bigger than 125, this fraction is smaller than that one, so it's in this interval, but it's going to be easy relatively to plug into this function. So f prime at 1/1000 is going to be 10 over 3 times the cube root of that is just going to be 1/10, minus 2 over 3 times we're going to get 1/10 squared, which is 1/100th. So we'll have 10 divided by 3 tenths minus 2 divided by 3/100ths. That's going to be 10 times 10 thirds minus 2 times 100 thirds. So that's 100 thirds minus 200 thirds. That's negative. So notice we do not change signs at this critical number, so it's not going to be the location of a max or a min. All right, let's check over here. Let's see, for a number bigger than that, I think I'm going to choose 1. So f prime of 1, let's work that out up here. That's going to be 10 over 3 minus 2 over 3, because the cube root of 1 is just 1, and of course 1 squared is also just 1. So that's 8 thirds, and that's positive. So my function goes down, and then up. Okay. So I can say that f is decreasing. Now this is kind of interesting, because it's decreasing, and then it starts decreasing again. When I have a situation like that, I don't need to, and I actually shouldn't, write it as 2 separate intervals. So you might be tempted to say it's the union of these 2 intervals, but if 0 is included in here, you just smush that together and write that as 1 interval. So from negative infinity to 1 over 125, including that finite endpoint, because this was a continuous function. Okay. And then I can say f is increasing on the interval from 1 over 125 to infinity. Excellent. Okay. Now, I also asked about relative maxes and mins. I can see from the shape of those arrows I'm going to have a min here. So f has a relative min when x equals 1 over 125. The value of the min is f of 1 over 125. So now I'm plugging not into f prime, but back into the original function f. So I maybe want to rewrite that one as well in terms of roots. So I can say this is 5 times the cube root of x squared minus 2 times the cube root of x. And notice, this is just 1/5 cubed. So its cube root is going to be 1/5. So this is going to be 5 times 1/5 squared minus 2 times 1/5. That's 5 over 25 minus 2 over 5. That's 1 over 5 minus 2 over 5. That's going to be a negative 1/5. Okay, so that's the information we get from f prime. Now I also asked for intervals on which the function was concave up and down, and the points of inflection, which is where the concavity changes. This video's been going for a little while, and YouTube doesn't like super long videos, so I'm going to stop the video, and we will pick up with this problem looking at the second derivative in the next video.